this video, we are going to talk about how to name alkanes using the IUPAC nomenclature. But before that, let's look at a few characteristics of alkanes. First of all, alkanes are saturated carbons. That means they do not have any double bonds or triple bonds. Every carbon atom has its valency fulfilled with hydrogen atoms. And every carbon atom in an alkane is sp3 hybridized. Alkanes follow the general rule CnH2n plus 2. That means you can generate the whole series of alkanes just by using this formula, CnH2n plus 2, where n is the any number starting from 1 to any other number. So for example, if you say Cn equals to 1, then we have 1 carbon and hydrogen would be 4. Okay, all right. Then also another characteristic is that since they are saturated carbons, they are pretty much unreactive. Okay, they have no motivation to react because the carbon atoms' valencies are completely fulfilled by hydrogen atoms. But they can be used to provide a scaffold for placing functional groups in them. Okay, so for example, you can take an alkane and put an OH group in there, and you can create an alcohol with it. Okay, so it's important that we start our studies with naming alkanes. Now also, alkanes can have CCs. They have CC single bonds and CH single bonds, but right now we are not going to place any functional groups on them, just carbon and hydrogen compounds. What are alkane isomers? Molecules with the same molecular formula but different kinds of arrangement of the atoms will result in the formation of isomers. So for example, we can have alkanes which are straight chain alkanes, or they can be branched chain alkanes. That would be an example of an isomer. So for example, you can have butane drawn like this, or you can have the same number of carbon atoms and hydrogen atoms but drawn in this manner. Okay, so if you look at this, both are C4H10. This is also C4H10. However, the way they are, the atoms are arranged is different. This looks like more like a branched chain, and this is a straight chain. These would be examples of isomers. Now, this type of isomerism is called as constitutional isomerism, okay, where the isomers, they differ in their atoms, how they are arranged in chains, or sometimes they may have different functional groups, or they may differ in the position of the functional groups. So there are three types of constitutional isomers. One, where you are looking from a straight chain to a branched chain, or second, where you have changed the functional groups. Here we have an alcohol functional group, and here we have an ether. Or you can place the functional groups at different positions. That will also give you an example of constitutional isomers. Now, let's try to use this into an example. The question is asking, can you draw two isomeric esters with formula C5H10O2? Okay? So, first of all, remember that esters are this linkage. Okay? It should have a carbon with a double bond to oxygen and a single bond to oxygen. And the formula is C5H10O2. So what are the two isomeric esters can you draw? So let's keep this as our functional group, right? And now that accounts for 1 carbon and 2 oxygens, but we still need to put 2 more carbons, right? So you can go ahead and write maybe CH2, CH3 on one side. So that covers 3 carbon atoms, and then we can again put a CH2 and CH3 on this side. So we have 1, 2, 3, 4, 5. Then count the number of hydrogens: 3, 4, 5, 6, 7, 8, 9, 10, and then the ester functional group. So this could be one possibility. Maybe we can draw this in a skeletal structure. Sometimes the skeletal structure gives you a better idea of how the molecule looks like. So this is the skeletal structure of this compound. What is the other way that you can draw this compound? So you can maybe keep 3 carbon atoms on one side. You have a still is ester linkage, but now you have only 1 carbon atom on the connected to the single bond of oxygen. So we have 1, 2, 3, 4, 5, or you can go ahead and write the condensed formula CH3, CH2, C, double bond O, single bond O. Oh, sorry. Put 3 carbon atoms. Okay. So it is CH3, CH2, CH2, C, double bond O, O, and then CH3. So this is a different ester. Sorry, right? Because you can see that here at the single bond oxygen atom there is only 1 CH3 connected. So these are examples of the isomeric esters where molecular formula is the same, however the structure is different. So here we have the solution for it. Sorry, this would have been another question is asking you, can you draw 5 different isomers of C6H14? Okay. So since there is no functional groups in it, here we can try to draw all the different constitutional isomers of C6H14. So first we can start with the straight chain. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. I'm going to draw the skeletal structures. That's 1. And then maybe we'll keep 5 on one chain. And then we can draw the one of them as a branch. Or you can move the branch to the middle carbon atom here. You can also have this one. I redraw that one more time. Okay. So you can draw this as 4 carbon atoms, like 1, 2, 3, 4, right? And then 2, you can place them over here. And then also do the same thing, 4 carbon atoms, but now you place 1 here, 1 here. Okay, so these are the 5 isomers of C6H14. If you count, if you look at the molecular formulas, they are all the same, but actually these are all different compounds. Okay, so these are examples of isomers, again, constitutional isomers. I had already talked about how to represent condensed and skeletal structures, so we can skip that. Okay, now you need to know the first 10 alkanes along with their formulas and names. You do not have to memorize the formulas, because remember, you can generate this whole series by just using this CnH2n plus 2 general formula, where you can keep on changing the n value and you should be able to generate this whole series of alkanes. You need to learn up to the first 10, that is up to decane, along with their formulas. Another important part you should know is what is an alkyl group. Okay? Because when we have a chain, a straight chain, then anything that is attached to the chain, which we call it as substituents, are generally alkyl groups. Okay? So what is an alkyl group? If you remove one hydrogen atom from an alkane, whatever is the remaining structure, that is an alkyl group. And we represent the alkyl group by R. And the name is the parent's name. Like, for example, if you start with the methane and remove one of the hydrogen, what is remaining is a methyl group. Okay, so we can draw this out. So we have methane is CH4, correct? So methyl would be CH3 because you have removed one hydrogen atom, so we have to leave one of the bonds free. Ethane is C2H6, the next one, and then the alkyl group, which is the alkyl, and then we can also name them, will be ethyl C2H5. Okay, so we can call this one was methyl, and this one will be ethyl. And C3H8 is the parent alkane. Parent alkane. The alkyl group that's derived from this is C3H7, which will be called as propyl because it's generated from propane, and so on. So if you have C4H10, then you have C4H9 as your alkyl group, and it will be called as a butyl group. Okay, so on, and you will have to learn up to 10 carbon atoms again. Here again, you can see the same thing that we wrote. We have in this table. Sometimes methyl, ethyl, propyl, butyl are abbreviated like ME, ET, PR, and BU. So it's common for us to write this as ME. So for example, I can take a chain, and then if I just write ET over it, it means that we have an ethyl group. Okay, or if I can put a ME over here, that means it is a methyl group. Okay, so remember, these are my substituents. Anything that is coming out of the chain, out of the main chain, is a substituent. Alright, then we can also have different types of alkyl groups, like a primary alkyl group, a secondary alkyl group, or a tertiary alkyl group. So it depends upon how the classification depends upon the connection site. So if the carbon atom is bonded to just one other carbon atom, then it is a primary. If it is bonded to two other carbon atoms, it is a secondary. If it is bonded to three other, it's a tertiary. And if it is bonded to four, it will be a quaternary. Okay? So like for example, this molecule, we can draw the skeletal structure to see it clearly. We have 4 carbon atoms on the chain, and then on the this carbon atom we have a methyl group here. Okay? And it's asking us to identify all the primary, secondary, and tertiary hydrogen atoms. If you look at, so first of all, you can identify the primary, secondary, and tertiary carbon atoms. So if we can put some color here, I will use red to represent all the primary carbon atoms, green to represent the secondary carbon atoms, and then we have one tertiary carbon atom which we can use a blue color, which is this one. Okay? And hydrogens attached to these will be named as primary hydrogen atoms, secondary hydrogen atoms, and tertiary hydrogen atoms. There is one tertiary hydrogen atom which is drawn with blue. There are 2 secondary hydrogen atoms which are drawn with green, and there are several primary hydrogen atoms which are all attached to these primary carbon atoms. So there are about 9 of them. They are the ones that are drawn in red color. Okay, so this is how you can look at the classification of different alkyl groups. The question here that draw structures of alkanes that meet the following: an alkane with 2 tertiary carbon atoms. Okay, so go ahead and draw it here. Or maybe we can take a different page. Draw an alkane with 2 tertiary carbon atoms. Tertiary carbon atoms. Draw this. It's not limiting us to a number of carbons, so we can just draw as many as you want. Okay. This would be an example of a carbon atom, which is, or a chain which has got 2 tertiary carbon atoms, right? So you see, this is a tertiary carbon atom, and this is a tertiary carbon atom. Anything that is attached to 3 other carbon atoms. So this is tertiary, and this is also tertiary. Going back, it's asking you another question, an alkane that contains one quaternary and one secondary carbon atom. So quaternary means you have something that's attached to 4 carbon atoms, and then, so maybe this one, this is a secondary carbon atom which is attached to 2 other. This one is actually a tertiary carbon atom, a quaternary carbon atom which is attached to 1, 2, then 4 carbon atoms. Okay, so that's the 2 examples. And then in the bottom example here is just asking us to label the different atoms. So it's asking what is number 6. If you look, it's connected to 3 other carbon atoms, so number 6 should be a tertiary, right? This is number 6. It's a tertiary. Then number 7, which is here, it's connected to 2 other carbon atoms, so it should be a secondary. 8, number 8 is over here. It's connected to 1, 2, 3, so it should be a tertiary again. And then 9 would be a primary. So it's connected to 1 carbon atom, so it is a primary. Right? Okay. So I think you got the idea of how to classify the different atoms as primary, secondary, tertiary, or quaternary. Moving on. Okay. Now, the problem comes when something is drawn and then you are wondering whether are they the same compound or are they different isomers, right? So for example, in these 2 structures, let's see, one is drawn in this way, another one is drawn in this way. Are they the same or are they different? How do you know it? The best way you can do that is by naming them, okay? Because we have certain rules which are called as the IUPAC nomenclature rules, and we use them to name organic compounds. In that way, if they have exactly the same name, then that means they are the same compound. But if they have different names, then that means they are not identical. So so we have to follow some rules to name them, and we follow this IUPAC, which stands for International Union of Pure and Applied Chemistry, where each molecule has 4 parts. One, we call it as the locant, which tells us where the substituents are, or if there are any functional groups, where they are. Prefix gives us what are the substituents, like is it a methyl, propyl, a halide, etc. And parent is how many total number of carbons are there. Is it a methane parent, a propane, or a butane, or a pentane? And finally, suffix, whenever we have a functional group, the name of the parent will change accordingly. For example, if you have an alcohol, it will have an OL, ol, as a suffix, like methanol, propanol, butanol, etc. Okay? But for this semester, we are not going to learn compounds with functional groups naming, except for alkenes and alkynes. This chapter particularly is dealing only with alkyl substituents or halogen substituents and parents up to 10 carbon atoms. Okay. So the different steps in naming the alkanes. Okay. All this. It's not complex. It's just naming the alkanes. Would be first find the parent hydrocarbon chain. Okay? So you have to find the longest continuous chain of carbon atoms to be labeled as the parent. Now it doesn't matter if the chain is bent or if it is straight. Okay? As long as it's a continuous chain of carbon atoms, you have to pick that as the longest one. If the chains are of 2 equal lengths, then how do you decide? Then you go with the chain that has the greater number of substituents. Again, remember what are substituents? Anything that is sticking out of the chain is called as a substituent. Okay? I can give you a better picture of this by drawing it as a skeletal structure. So, as I keep saying that sometimes skeletal structure gives you a better idea of how the molecule looks like. So, for example, if if you had 1, 2, 3, 4, 5, 6, okay, and then here we have two groups here, okay, so you will look for the longest chain. So here we have a chain which we can start from here 1, 2, 3, 4, 5, 6, or you have 1, 2, 3, 4, 5, 6. So the longest chain looks like the 6 carbon atom chain. So we can highlight that with this red color here. Okay, so this is my parent. I decided to use this as my parent, which is a 6 carbon atom chain. And then anything that's sticking out of the chain, so let's color that. Maybe this green substituent here and these are called as the substituents. Okay. Now in the earlier slide we saw that if you have two chains of equal length, so 1, 2, 3, 4, 5, 6. So we have 1, 2, 3, 2, 4, 1, 2, 3, 5. So if you have a chain like this, right? So if you look, this one also has a chain which has got 6 carbon atoms as the longest chain, right? If you have 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, right? So if you use this straight chain here, 1, 2, 3, 4, 5, and 6, right? So this is a 6 carbon atom long chain. Or you have another option here. If you look at this green one, okay, so it's 1, 2, again 3, 4, 5, and 6, right? We have two possibilities of this chain. One is that green one and the other is a red one. Both are 6 carbon atom. And how do you choose it? So the rule is that you will choose that chain which gives you the more number of substituents. So for example, if you had chosen the red chain, then you would only have, so if you had chosen the red chain, right, this straight, the chain that's here, then you will only have this one as your substituent, okay, this only one substituent. On the other hand, if you are choosing the green one, then you have a this substituent, methyl, and a ethyl, right? So that's why the green substituent or the green chain is our correct one. Okay, so let's redraw that. Okay, so I will be taking this one. Okay, so I will be taking the green chain. This one. That's my chain. 1, 2, 3, 4, 5, 6. Okay, then we have some substituents sticking out of it, which is this one and this one. Okay, since there are two of them, so now this will be the correct way of doing it. Okay, now going back to the next rule, that means once you have picked out your longest chain, then you decide to put a number to the substituents. Okay, always number to give the lowest number to the substituent. Okay, so here again, let's go back to the previous example I had. So here we decided that in this first chain, the red color is my chain, right? So, or my parent chain. So how will I number it? You have to start from that end, which will give you the lowest number. Now, in this case, you could have numbered from your left side or the right side, and both would have given you the lowest number to the substituent, which is this methyl group. Okay, so I will go ahead and number them. Start from here. 1, 2, 3, 4, 5, 6. Once that means my parent would be a hexane because it's a 6 carbon atom. Once you number them, then you name the substituents now. So at the second position, you have a methyl, okay, So at the second carbon atom, you have a metal, and then at the fifth carbon atom, you have another metal. Correct? So now you have identified everything. You are ready to name this compound. So the name of this compound would be 2, 5 dash dimethyl hexane. Okay, that would be the correct name of this compound here. Because of the second position and the fifth position, you have methyl, but since there are two methyl groups, we will say dimethyl. Di stands for 2. And then always remember, between two numbers, you have to separate them by a comma. And anytime you have a number and a word, you separate them by a hyphen. We are ready to name this one now. Okay. Now here again, you have to start numbering from that end, which will give you the lowest number to the substituent. So if you start from the top here, you will give this 1, 2, 3, 4, 5, and 6. If you had started from this other end, then you would have had 1, 2, 3, 4, 5, right? Which will be 4 and 5 higher numbers to the substituents. So we will not start numbering from the right side, but from the left side, or from the top here. Okay. Okay. So now we are ready to name this one. So now you have a methyl group at the second carbon atom. You have a methyl group, and at the third carbon atom, you have an ethyl group, right? It's an ethyl group, see, CH2, CH3. This is a CH3. Okay? So how do we name it? Always put the substituents in alphabetical order. Okay, so you have to put them in alphabetical order while naming. So this will be called as 3-ethyl, okay, 3-ethyl 2-methyl. The parent again is a hexane. 3-ethyl 2-methyl hexane. That would be the correct name of it. So why ethyl first? Because E comes first, then M, right? So you have to put, even though the number this is higher, that doesn't matter. You have to put the substituents according to their alphabetical order. Okay. Let's look at this example here. This is telling us an incorrect way of numbering, where again you started to give numbers from this end, but it's giving a higher number to the substituents, whereas if you started from here, see, the first substituent should get the lowest number. Always remember, the first substituent should get the lowest number. If you started from here, the first substituent would get a number 4, so this is the incorrect way of. And then another question arises that if the first substituent is the same distance from both ends of the chain, then you try to give the second substituent the lowest number. Okay, so for example, this one, draw 1, 2, 3, 5, 6, 7, 8. So let's draw 1, 2, 3, 4, 5, 6, 7, 8. Then here we had this one. So I just read through the top compound in a skeletal structure, and you can number from here. So we have 1, 2, 3, then we have 4, 5, 6, 7, 8, 9. Okay, that's how we have numbered it. So we have substituents at the second position. Sorry, third position, right? See, substituent the third position, at the fourth position, and the seventh position. Okay. Now, if you had started numbering from this end, okay, so here with the numbering from the left side, you have substituents at the third, fourth, and seventh. Now, if you start numbering from the other end, 1, 2, 4, 5, 6, 7, 8, 9, right? then you have substituents at the third, so third doesn't change. The first substituent is still at the third position, but then the second substituent is coming at the sixth position, right? It's sixth position, and then at the seventh position. So the second substituent is getting a higher number here, so we will not use the numbering from this end of the chain, but we will use the numbering from the left side of the chain, okay, and give these as the correct numbers, okay. Alright, so we will go ahead and redraw that same compound and name it correctly now. Let's redraw that first. Since we decided that our numbering should be, so maybe if we highlight the parent chain with red color first. So this is the longest chain. Okay, once you identify your longest chain, then you can identify your substituents here. These green ones are your substituents. And then since we decided that we are going to number from this side, we'll number 1, 2, 3, 5, 6, 7, 8, 9. Okay. So if you look at, we have at the third position an ethyl group, at the fourth position and seventh position we have methyl groups. So remember alphabetical order, correct? So we will name this compound as 3-ethyl. Remember, in between a number and a word there should be a hyphen. Then dash again, because you're going to put another number here, which is 4, comma 7, two numbers always separated by comma, 4, comma 7, and then again a dash, and then we have dimethyl. Remember, there is two methyl groups here. Both the green ones here are the methyl groups. Dimethyl, and then what should be my parent? It's a 9-carbon atom chain, so it should be a nonane. Okay, this is all one name. 3-ethyl 4, 7 dimethyl. Okay, these are some more examples of naming different compounds, and you can look at more examples from your textbook. So this one is a 3-methylhexane, because at the third position, so we remember from here, third position you have methyl group, so it's 3-methylhexane. Here we have 3-ethyl. Remember, we talked about putting alphabetically in the alphabetical order. So we have the third position, see, ethyl group here, and then at fourth we have a methyl, and at the seventh we have another methyl. So 4, 7 dimethyl nonane. Then we have here same thing, ethyl, because it's alphabetical order, it comes first, then M, so 3-ethyl 2-methylhexane. Another one with a heptane chain, and the next one with hexane. Sometimes you may get branches attached, and they may be named as a separate entity of its own. So for example, this one can be separately named as a 2-methyl propyl substituent, and then name the entire compound. So this one, for example, see, this whole thing is a separate group. So you call this as a 2-methyl-butyl, right? So because this is a butyl group, and the second position you have it. So this is my 1, 2, 3, 4. Okay, so 1, 2, 3, 4. So at the second position you have a methyl. So you put them in parentheses, 2-methyl-butyl, and then undecane, because you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's an 11-carbon atom chain which has a name as undecane. Alright. One more thing we need to discuss before we conclude this part of our video is that sometimes you may get branch substituents which have common names. Like for example, the propyl substituent can branch out and it may look like this. So at that time it's called as an isopropyl. And iso will be part of the alphabetical order. So that means if you have a isopropyl group and a methyl group as your substituent, then isopropyl will be written first, because I comes first before the methyl methyls M. Okay. Same thing with butyl. This is a normal butyl, but there are three different ways by which you can represent. If you draw it in this manner, then it is called as a sec butyl. Okay, because see, it's connected to it. The parent chain is connected to a secondary carbon atom. So this wiggly thing that I have here is just the main chain. Okay, parent chain. And to the parent chain, if you have this as your substituent, then this is called as a secondary butyl group. If to the parent chain, which is this one, again, this wiggly thing is my parent chain. If you have this as your substituent, where it's a two methyl groups attached to this one, so we call it as an isobutyl. And if you have this form of the substituent, then we call it as a third butyl, T-butyl. Okay, sometimes you write it as T-butyl because it's a tertiary carbon atom. Okay, highlight this. This is my tertiary carbon atom. Here I have a secondary carbon atom. That's why it's called a sec butyl. And here we have the isobutyl part. See this? Whenever you see this Y kind of shape, right? See, here also it's called as isopropyl. This is isobutyl because you have 1, 2, 3, 4 carbon atoms, right? So this is the total. That's the whole thing. So please make sure that you are also looking into the common names of these substituents. Okay, so maybe one more slide to for examples. This is a different one where you see that you have identified we are trying to identify which one is the main chain here, okay, and then try to number them, right? So in this case, we call this as the first point of difference rule. That means if you look at the chain, this is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbon atom chain, which is my longest chain. Now, which side will you start numbering from? Okay, so always number from that side, which will give you the first point of difference rule. Okay, so that means you start from here, 1, 1, no, both look the same. But the second carbon atom, you have a methyl group here, you don't have a methyl group. So there you go, you found the first point of difference. So you start numbering from this end. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. At the 7th and 8th position, also you have methyl group. So this compound will be called as 2, 7, 8 dash trimethyl, because there are 3 methyl decay. And finally, this one, if you look, if this is the same thing, we are going to have 4 substituents here. Okay. Oh, sorry, 5 substituents. And then same thing, how will you start numbering them, right? Which side? So if you look at this is 1, both ones have no difference, but at the second position, here we have 1 methyl group, but here we have 2 methyl groups, okay? So that means I decide to go this way of numbering 5, 6, and 7. So that at the second position, you have 2 methyl groups. So you will put 2, 2. And at the 6th position, again you have 2. So 6, 6. Then 7, because at the 7th you have a 5th methyl group. Okay. So let's highlight all the methyl groups here. See, this is a substituent. This is a substituent. Another methyl, and it's 4th methyl, and then another. So all these blue ones are your substituents, but you have to make sure that even if they are attached to the same common atom, you have to separate them by commas and say it as 2, 2, and then 6, 6, because it tells that there are 2 methyl groups there. And then 7, because there's only 1 pentamethyl octane. So I hope this video is going to help you understand naming. You can practice some more with the given worksheets that are posted, or you can take some more examples from your homework.